everyone, welcome to JGK Master Class. Guys, in today's video, we are going to learn about 3 and 4 membered heterocyclic compound containing oxygen and sulfur called oxirane, thyrane and oxetane. I have already uploaded one more video on 3 and 4 membered heterocyclic compound which contains nitrogen called aziridine and azitidine. If you haven't watched that, I'll share the link in the description box. You can watch it. And this topic is important for all the students, those who are studying chemistry. And here we will discuss the previous year questions of PCU. So the first question is, sketch a synthesis of oxirane. So here we will synthesize oxirane. What is oxirane? Oxygen in a three-membered ring is called oxirane. So how we are designing here? We are seeing halohydrin here. You can notice one OH group, and at adjacent carbon you are having halogen group here. In the presence of base, we know it will abstract the acidic proton and generate a nucleophile, and the nucleophile will attack on the electrophilic carbon with the loss of NaBr here, and you will get the formation of three-membered ring containing oxygen. So here this is one method to design oxirane. There are so many methods which you can learn to design three-membered containing oxygen. Since the question belongs to 2 marks, you can mention only one synthesis. Write a comparative account of the ring opening reactions of oxirane and oxetanes. So oxirane, we know it is a three-membered ring containing oxygen. Oxetanes are four-membered ring containing one oxygen. So here they are talking about the ring opening reaction of both. As we know, three-membered ring and four-membered ring are having strain, and so you will see ring opening reaction for these compounds. So we will discuss first for oxirane. As you can notice that because of a strain present in the oxirane ring, it is highly labile and ring can be readily cleaved by variety of reagents. So here we will learn one example. So this is an oxygen containing three-membered ring which is substituted on the one carbon having methyl group. The condition is acidic condition. So in the presence of acid, we know the lone pair of the oxygen present will take this proton and the oxygen will become positive. And now since this is the having the positive charge, the two adjacent sigma bond will try to neutralize this charge. So how it is going to happen? You have the methanol given here as a solvent. So the methanol, the oxygen of methanol will act as a nucleophile and will try to attack either one of the carbon. Two possibilities are there. One is having the substitution, the other is without substitution, and so followed by the sigma bond which is going to give its electron to the oxygen. So we know that the attack will take place through the SN2 mechanism, and SN2 mechanism favors where you have less sterically hindered side. So the most favorable path which will give you the major product is which will attack on the less sterically hindered carbon side. So OMe will come to this carbon where you have two hydrogen present, and the ring will open in the way so that you have Me and OH attached, you can see, on the same carbon. So OMe is attached to the less sterically crowded side, and this is your major product. Otherwise, you will get the minor product because of the sterically crowding if OMe will attack and comes near to the carbon which is having Me group. So you can see here, since the mechanism goes through SN2 mechanism, we can see the product is going to form with the less sterically hindered side. And if we consider the oxetane, it is also cleaved under rigorous conditions by such reagents because four-membered ring is slightly having less strain compared to three. So therefore we have written vigorous condition. So one example also we will see here in the presence of methylamine, and the lone pair on the nitrogen will act as a nucleophile. Since it is symmetrical, there is no substitution. You can open it from either side and you will get the following product. So now next question is, what are thyranes? Thyrane is, we can see a three-membered ring having sulfur, and how they are synthesized. So thyrane, you can see we have already seen that three-membered ring comprising of one sulfur atom. It is also designated as ethylene sulfide, or one can also call it thiocyclopropane. Now we'll see the synthesis. You can find one more question that give any two synthesis of thyrene from epoxide. So as we can see here, oxirane are also considered or also called epoxide. So we are seeing here one structure, oxirane or epoxide, and you have SCN having a negative charge which is acting as a nucleophile. Being symmetrical, it will attack to either of the CH2 and will open the ring, and oxygen will accommodate the negative charge. And we know here in SCN, carbon is having the electrophilic center, so this oxygen will attack to the carbon, and the negative charge will now come to the nitrogen. So in this way, and following by the loss of OCN, the negative charge will be accommodated by sulfur, and this negative charge is eliminating, and the OCN, which is giving you here the three-membered ring containing sulfur. So this is how from oxirane to thyrane we have designed, or you can say from the epoxide to ethylene sulfide we have designed it. Another method you can notice, which is again very simple, you have a substituted thiourea, uh, and you have the oxirane ring which is substituted here, and if you do the reaction among the two, you will get the thyrane with the loss of urea elimination. So here again we can see the epoxide, or you can see the oxirane, and from which we are converting into the sulfur containing three-membered ring. And so you can design the thyrane in by the following two methods. I hope you have noticed all these questions in the previous year question paper, and you can note down all the answers which we have discussed here. And I hope it will be helpful for you for your further upcoming examination. All the best. See you in the next video.